Hey everybody, this is the Advanced Algebra Trig Pre-Calc video on P3. You're going to be solving linear equations and inequalities. Essentially, that just means one variable equations and one variable equalities. Now, in the past when I've done this, I have not done the most easy problems, I should say. Kind of just dove into the difficult ones and gave you guys a couple examples of those, but your homework does have a couple of those easy ones. So we're going to start by solve the following equations. And this video should be relatively short. Okay, so I'll make this number 1. And the second thing we're going to do is that we're going to be solving inequalities as well. All right? So the first one we're going to look at is 2 times the quantity x minus 3 minus 17 equals 13 minus 3 times x plus 2. Yeah, totally just diving right in it, right? Okay, so I'm seeing parentheses in both ends, and what that's going to indicate is that I need to distribute, okay? So we're going to start by distributing this. So we're going to have a 2x minus 6 minus 17 equals. Now, it may be tempting to take the 13 minus 3 and making it 10, but you don't do that because remember you have to multiply before you subtract. I'm going to distribute this like a negative 3. So 13 is going to go here. Negative 3 times x is a negative 3x. Negative 3 times 2 is a negative 6. All right? Then the next thing I'm going to do is simplify both sides. So I need to combine those and make it 2x minus, that's 23, equals, I'm just like to have my x first. It totally doesn't matter. Negative 3x plus 7. All right? And then what I'm going to do next is I'm going to get my x's together. I'm going to add a 3x to both sides. And then I am going to add 23. And divide by 5. Okay. Kind of sucks you guys aren't in front of me, but in the past, kids haven't really had that much problems with something like this, so hopefully you don't. And I started with something super complicated. So if I want to check this, all I do would be to substitute the 6 back here and here. So if I would check it, okay, I'm going to have 2 times. If 6 goes in here, 6 minus 3 is 3. That'd be minus 17. That needs to equal 13 minus 3 times. This 6 goes in here, 6 plus 2, that's 8, right? So this would be 6 minus 17. Wouldn't that be a negative 11? And this would be 13 minus 24. Wouldn't that also be a negative 11? And that checks. Do you have to check all of them? No, but it's a good thing to do. Okay, so these kind of get long, so I'm going to use another sheet of paper for the next one. All right, next one. This would be B. Okay, we're going to have an x plus 3 over 6 equals 3/8 plus x minus 5 over 4. All right, so that is what I'm looking at in this one. Oh my gosh, fractions. I do not like fractions, you guys. So what I want to do is I want to come up with a way that I wouldn't have a fraction, because if I multiply everything by a number, the same number, if it gets rid of my fraction, I can do that, okay? That's a math, it's legal in math to do that, okay? So what I would do is think about, okay, what would be something that would divide out evenly with a 6, an 8, and a 4? Okay, 4 doesn't go into all of these. 12 might be one you think of, but 12 doesn't go into 8. 16 goes into 4, but not into those. And it goes into 8, but not into 6. 24. If I would multiply this guy by 24, wouldn't the 4 divide out? If I multiplied this by 24, that would divide out. And if I multiplied that, 24 is my magic number. And I'm putting it over 1 because I'm multiplying by fractions. I'm a big fan of doing that. All right? So here we go. 24 divided by 6 is 4. So we're going to have 4, and then I need to put in parentheses x plus 3. That equals, all right, 24 divided by 8, that's 3. 3 times 3 is 9. Plus, my next one, 24 divided by 4 is 6. 6 is being multiplied by x minus 5, so it's going to be a 6 times the quantity x minus 5. All right, next thing I'm going to do is I'm back to the other problem I just did. Let's distribute the 4 through. 4x plus 12 equals 9. The 6 through, 6x minus 30. Combine like terms on the right side. That's negative 21. All right, and I've watched kids solve these in the past, and you guys probably don't have all the steps I have, so I'm going to make things easier on myself as well. At this point, I probably would subtract a 4x. That gets rid of the 4x, and then I'm going to add 21. All right, this is a 2x. This is gone. That equals, what, 33? And I'm going to divide both sides by 2. So x is going to equal 33 over 2. You can totally check it, but I have it in front of me. I've done this in the past, so I know that that's the right answer. All right? So in the past, sometimes what I would do is I do another one. I will do another one just in case you guys have questions and you want another one done. If you don't, you can go ahead and you can go past C. But if you want it, C is 5x or 3x over 5 minus x minus 3 over 2. That's going to equal x plus 2 over 3. So then I got to think of the magic number that would divide the 5, the 2, and the 3 out. Well, 6 would work for these two, but not this one. 10 would work for these two, but not that one. 15 wouldn't work for that one, so it looks like I'm going with 30. All right, so here we go. 30 divided by 5 is 6. So we're going to have 3x times 6, that's 18x, minus 30 divided by 2 is 15. That's going to be 15, and then in parentheses, x minus 3. That equals 30 divided by 3 is 10. 10, and then the x plus 2. Now, is 30 the only one that works? No. You could totally use 60 or 90. I tend to use the smallest one because I like to do math in my head. Okay? All right, next thing I'm going to do is distribute this as a negative 15, so it's going to be, sorry, I forgot my x, 18x minus 15x plus, what, that's 45. That equals 10x plus 20. All right, combining like terms here, that's going to give me a 3x plus 45 equals 10x plus 20. And then the next thing I'm going to do is I'm going to subtract 3x here, subtract 20. This is going to be 25 equals 7x. Divide by 7, x equals 25 sevenths. Okay, and I'm looking at my answer and it's right. All right, so that was just the extra one for that. All right, so looking at what I have to do. Sorry, I was getting a call. Hopefully nothing popped up on my screen. I'm just asking for my car warranty. Yeah, whatever. Okay. Last ones. Solve the following. So I think this would be our number 2 idea of the day. Yep, number 2. Solve the following inequalities. And we're going to give our answers in a couple ways. Because you guys need to be able to use interval notation, okay? And that's super important, so we're going to try to do these on a number line, and then we'll also do them in interval notation. All right, so I know I have at least 3 of these I'm going to do. A. Let's start with this one. 9 is greater than 3x plus 2. All right, so here's the thing. These are pretty much going to be like your equations. I probably should have noted too, and your equations right here, when I taught algebra last year, I had a lot of kids who like the line down the middle. If you're a line down the middle kind of kid, that's totally fine. I just generally don't do that all the time. Okay, so here's the thing. We want to get the x by itself, but there are different rules for inequalities, you guys. So we have to kind of take that into account when we're doing things because you could have different things happening. All right? So before we get to that, let's just see, okay? Let's think about it. If I had 2 numbers, if I had like -4 and 8, let's do those. Now, we always know that they're not equal to each other, okay? We know that -4 is less than 8. The question is, does adding, subtracting, multiplying, and dividing keep this side smaller than that side, okay? So what I'll do is I'll just generate some kind of table, okay? The first thing I want to do is let's add a positive. So let's just add, I don't ask kids for this, let's just add 7 to both sides. -4 plus 7 is 3. 8 plus 7 is 15. 15 is still greater than 3. No change. All right, let's subtract 7 next. Negative 4 minus 7 is negative 11. 8 minus 7 is 1. 1 is still greater than negative 11. No change. Okay, I probably should say subtract 7 to both sides. Now, here's the thing. I'm going to throw in some negative numbers here, but I'm not going to add a negative number because isn't adding a negative number the same thing as subtracting? And subtracting a negative number is the same thing as adding. So it doesn't even pay to do those. So I'm not going to worry about those. Let's start with multiplying by a positive. Let's multiply by 2. Okay. If I multiply this by 2, this would be negative 8. 2 times 8 is 16. 16 is still greater. No change. And I probably should have said multiply 2 to both sides. And we're always going to the original one. No change. All right, then I'd probably divide by 2. All right, negative 4 divided by 2 is negative 2. 8 divided by 2 is 4. 4 is still greater. No change. Now, if I would multiply by a negative 2, isn't that different than dividing by 2? See, adding and subtracting positive and negatives, they're kind of the same, but multiplying, dividing, they don't have a relationship. So let's multiply by negative 2. Negative 4 times negative 2 is 8. 8 times negative 2 is what? Negative 16. Which one's bigger? 8. Ooh, we got to change. All right, that's super duper important. I'm going to star this because we're going to see if there's another change. Let's divide by a negative number. Let's divide by negative 2. Because dividing by a negative is not the same as multiplying by a positive. So I can't do the whole thing I did with the adding and subtracting. Dividing. Negative 4 divided by negative 2, that'd be 2. 8 divided by negative 2 is what? Negative 4. Which one's bigger? 2. There is a change from the original one because this is the original one. All of them are the same until I get to there. Change. All right, guys. So here it is. If you multiply or divide both sides of an inequality by a negative number, you flip the inequality. So if you multiply or divide both sides of an inequality by a negative number, switch the direction of the inequality. All right, got to do that. Super duper important. Okay, I know I did that in algebra last year. All right, so that's my old stuff. Let's get back to here. Okay, we got 3 of them. All right, so here we go. We're going to get the x by itself the same way. I'm going to be asking, do I switch the inequality around? Subtract 2, right? 7 is greater than 3x. We don't switch the inequality around because we didn't even multiply or divide. Next, divide by 3. Dividing both sides by a positive 3, does that flip this? No. We're going to have 7/3 is greater than x. Now, usually the math way of doing it is to have the x first and then the 7/3 on the other side. So this says that x is less than 7/3. There we go. All right. On a number line, how that would look, 0. Let's say that's 7/3. Okay. If x is less than 7/3, are we going to go to the right or to the left? We're going to go to the left, right? Because it's got to be less than that. All right. As an interval, we haven't done that for a while. Okay. From an interval, all my numbers, we go left to right. My answers go from all the way to the left forever until 7. Oh, and I forgot. We need to put up parentheses. So going to left forever is negative infinity, and it goes to 7/3. Not including 7/3, infinity is always in parentheses. All right. Next one, negative 5 is less than 2x plus 8, which is less than 10. All right. So same thing here. Here's what we're going to do, you guys. We're going to solve this guy and this guy at the same time. Okay. So whatever I do to the middle, I have to do to both ends. All right. And if you need to split them up and see it, this is just saving some space, I guess. All right, here we go. To get the x by itself, first I'd subtract 8 here, subtract 8, subtract 8. 8's gone, 2x is here. Does subtracting 8 flip the inequalities? No. So we're going to have negative 13 is less than 2x, which is less than 2. Next, to get the x by itself, we're going to divide everything by 2. That gives me an x here. All right, dividing by positive 2, does that flip them? No, it'd have to be negative 2. And so negative 13 halves is here. 2 divided by 2, that's 1. All right, so looking at what I have here, I'm going to draw my number line first. Sorry, I was looking at my answer. I think I kind of messed up on my actual answer. I'm just double checking. So subtract 8. Yeah, I divided by something here. But we're good. I think I have this right now. If you were in front of me, I'd say, am I right? And if I'm wrong, just tell me. I like people to give me advice on what I'm doing right or wrong. All right. So on your number line, 0, negative 13 halves. 1 is here. Doesn't matter how close we are to 0. We're looking at everything between negative 13 halves and 1. We are not including them, which means my interval would be negative 13 halves to 1. And then there we go. And there we go. Okay, so that is that one. So I haven't had to flip anything yet, which is kind of nice. Let's see how this last one goes. C. Negative 7 is less than or equal to 5 minus 6x. All right, we want to get the x by itself. Let's start by subtracting 5. Negative 7 minus 5 is negative 12. All right, this we have a negative 6x. And we don't switch the inequality around because we just subtracted 5. Next, let's divide by negative 6. Ooh. Since we divided both sides by a negative, this guy flips. So I'm going to have an x here. Negative 12 divided by negative 6 is 2. Now, just like the last one, you want the x usually first and then the number here. So it says x is less than or equal to 2. Here we go. 0, 2. X is less than or equal to 2. That would be a bracket. So going left to right, we would have negative infinity to 2. And that would be in parentheses. All right, so you're going to have a couple on this. Every year, this is one of those good assignments kids just enjoy, just solving for x. I hope you guys have a blast. If you have questions, come to a Google Meet. Good luck.